Hi everyone. In this video we are going to explore basic concepts and computer evaluation. The relationship between architecture and organization is very close. Changes in technology not only influence organization but also result in the introduction of more powerful and more complex architectures. Generally, there is less of requirement for generation-to-generation compatibility for these small machines. Thus, there is more interplay between organizational and architectural design decision. In describing computer, a distinction is often made between computer architecture and computer organization, although it's difficult to give precise definition for these terms. Computer architecture refers to those attributes of a system visible to a programmer, or those attributes that have a direct impact on the logical execution of a program. Issues such as instruction format, instruction opcode, registers, instruction and data memory, in addition to the effect of the executed instruction on the register and memory, and an algorithm for controlling instruction execution. While computer organization refer to the operational unit and their interconnection that release the architectural specification. For example, of architectural attributes include the instruction set, the number of bits used to represent various data type, I/O mechanism, and techniques for addressing mode. While in organizational attributes include those hardware detail transparent to the programmer, such as control signals, interfaces between the computer and peripherals, and finally the memory technology used. For example, it's an architectural design issue whether a computer will have multiple instructions. It's an organizational issue whether that instruction will be implemented by special multiply unit or by mechanism that make repeated use of the add unit of the system. A computer is a complex system. Modern computers contain millions of elementary electronics components. How then can one clearly describe them? The key is to recognize the hierarchical nature of most complex systems, including the computer. Structural meaning the way which is the components are interrelated, while function is the operation of each individual component as part of the structure. In terms of describing, we have two choices: starting at the bottom and building up to complete description, or beginning with the top view and decomposing the system into subparts. In general terms, there are only four operations: data processing, data storage, data movement, and finally control. Data processing, the data may take wide a variety of forms, and the range of processing requirement is broad. However, we shall see there are only a few fundamental methods or types of data processing. Data storage, even if the computer is processing data on the fly, means data come in and get processed and the result go out immediately. The computer must temporarily store at least those pieces of data that are being worked on at any given moment. Data movement, the computer operating environment, consists of devices that serve as either sources or destinations of data. When data are received from or delivered to a device that is directly connected to the computer, the process is known input-output, and the device is referred to as a peripheral. When data are moved over longer distance to or from a remote device, the process is known as data communication. Finally, the control within the computer, a control unit manages the computer resources and organize the performance of the functional parts in response to these instructions. We now look in a general way at the internal structure of computer. We begin with the traditional computer with a single processor that employs a microprogrammed control unit, then examine a typical multi-core structure. There are four main structural components: CPU, main memory, I/O, and finally system interconnections. CPU controls the operation of the computer and perform its data processing function, often simply referred to as a processor. Main memory stores data. I/O moves data between the computer and external environment. And finally, system interconnection, some mechanism that provide for communication among CPU, main memory, and I/O. The most interesting and in some way the most complex component is the processor. Its major structure component as follows: control unit, arithmetic logic unit, registers, and CPU interconnection. As we mentioned, modern computers nowadays have more than one CPU inside the processor chip. Computers generally have multiple processors. When these processors all on a single chip, the term multi-core computer is used, and each processing unit is called a core. To clarify the terminology, this slide defines them. We have a CPU, that portion of a computer that fetch and execute instructions. It consists of ALU, control unit, and register. Core, individual processing unit on processor chip. A core may be equivalent in functionality to a CPU or a single CPU system. Processor is a physical piece of silicon containing one or more cores. Now we can see the video, including nowadays processor have GPIO. GPU it means graphical unit, processor unit. That's make the video streaming is easier and faster. Another significant feature of modern computer is the use of multiple layers of memory, called cache memory, between the processor and memory. This part will be explained later in chapter 4, but in brief, cache memory is smaller and faster than main memory, and is used to speed up memory access by placing in the cache data from main memory. This figure is a simplified view of the principal component of typical multi-core computer. Most computers, including embedded computer in a smartphone and tabs, plus personal computer, laptops, and workstations, are housed on the motherboard. The most significant element on the motherboard are the chips. A chip is a single piece of semiconductor material, typically silicon, which electronic circuit and logic gate are fabricated. The resulting product is referred to as an integrated circuit. It will be instructive to look at some real-world examples that illustrate the hierarchical structure of the computer. This figure, a photograph of the motherboard of the computer built around two Intel quad-core Xeon processor chip. Following our top-down level strategy, this figure we can zoom in and look at the internal structure of the processor. And this figure photograph of the processor chip. This chip has 2.75 billion transistors. The superimposed label indicate how the silicon real estate of the chip is allocated. This figure depicts the key concept in an integrated circuit. A thin wafer of the silicon is divided into a matrix of a small area, each of few millimeters square. The identical circuit pattern is fabricated each area, and the wafer is broken up into chips. Each chip consists of many gates and or memory cells, plus a number of input and output attachment points. We can see now this video called sand to silicon or sand to processor fabrication. Enjoy the video. That's all for this video. Thank you so much.